Hello there, Fiona. This is a first. I've never done a video just for one student. So I had a look at the questions that you got wrong, and this is just to kind of go over with you, where the mistakes were and why the correct answers should have been what they were. So here you have number 6. So basically, approximately 52% of all recent births were boys. In a simple random sample of 100 recent births, 49 were boys, 51 were girls. And the most likely explanation for this difference is what? Okay, well, bias, that's basically when you have underrepresentation or overrepresentation here. That's not the case here. We're just basically taking a random sample of 100 recent births. Okay, now the answer is B. Okay, whenever you're doing sampling, there's always going to be some variability. I mean, think of it like this. When you flip a coin, the probability that you get a heads is 50%. But if you flip it 100 times, you're not necessarily going to get 50 heads. You could keep doing this experiment and you're always going to get a slightly different number of heads. So in this case, if I was to completely, continue doing this experiment with the births of girls and boys, I would always get a subtly different answer, and that's down to the variability in sampling. Now, your response was a sampling frame that is incomplete. A sampling frame is just basically making sure that we have all the people that we were supposed to be interviewing. So in this case, our sampling frame would be 100, so that's not incomplete. And actually, that wouldn't make a lot of sense for this one. Okay. All right. Your next question was 16E. So let me just go ahead and find that one. Here we go. 16E. Now, with these particular types of questions, especially the lengthy ones, it's often a good idea to kind of write down or maybe complete part of the question in the process so that you can actually understand what's really going on. So what we're doing here is we're doing a two sample proportion test, a two proportion Z test. So we're looking at the difference between two proportions. So here I've got the proportion of women and here I've got the proportion of men. Now, whenever you're doing a two proportion Z test, remember you have to check three conditions. You have to see if the data was obtained randomly. You have to make sure that the 10% condition for independence was crossed off, and you also have to check your large counts. So the random one checks off because it was done randomly for both groups. The 10% condition is all good because if you multiply 40 by 10 and 50 by 10, you get way more. You get way less than the 4,600 and the 4,500. So that's also good. The one that doesn't hold water is the large counts, because if you do the number of women multiplied by the proportion of women, you get 38. But if you do the number of women multiplied by 1 minus the proportion of women, you only get 2. And remember, they have to be, each of these values has to be greater than 10. So therefore, you would not be able to use a two proportion Z test for this data, okay? Because the conditions have not been met. Now you chose D. Because of the relative sizes of the populations and samples, a two proportion Z test would be valid. Well, the size of the samples was actually okay. All right, so therefore, we would omit D. But E is definitely not going to be, it's definitely going to be the correct answer. All right, the next one you were after was number 17. So number 17 is really just using, looking at the sampling distribution of means. So when you look at a sampling distribution of means, the mean of the sampling distribution will be the same as the mean that you get. So that'll be 2.3. However, the standard deviation of the sampling distribution of means gets changed. It will become 1.3, the original standard deviation, divided by the square root of the sample size. So if you want to figure out the probability that the mean value is actually less than 2, you can standardize it, which they've done in these questions right here. And it's always going to be the observed value minus the mean divided by the standard deviation. So in this case, the observed value is 2. The mean of the sampling distribution is 2.3, and the standard deviation of the sampling distribution is 1.3 over the square root of 40. So therefore, the answer would be A. You chose B. You just got to remember that when you're dividing, you have to divide by the standard deviation of the sampling distribution, which takes into account the sample size as well. Okay, all right, 2 more left. The next one was 33. So let me just quickly jot to that one. All right, here we go. All right, so 33, very wordy, so you might have to read this a few times. But basically, what they're doing is they're taking an unknown number of people, okay, and they're basically looking at these 85 variables in each different person. And they look at how they perform both before taking the vitamin and then how they do after taking the vitamin. And then they're basically doing 85 different matched pairs tests. Okay, so it's a lot of work. So if you look at these responses, you chose A, so it's not going to be this one because when you have 2 out of 85, it's actually very easy to actually get a result of two tests being significant out of 85. So that doesn't mean that it's going to improve the overall health of adults. Okay. Also, B is not going to be the case because there's simply no evidence of that. Okay, where do we get that? We're not told that in the question, so therefore we can't assume that. For D, 85 is not large enough to draw a conclusion. Well, this is a matched pairs t-test. It doesn't matter how big the sample size is. All right, you could do a matched pairs t-test with 2 or with 3 or with 4 people. And this whole idea of only having an even number of variables, well, that's just crazy. So the answer has to be C. All right, there is insufficient evidence that the vitamin improves the health of adults because at the 5% level, yeah, it's actually really easy to statistically get significant results in 2 out of 85 tests. You could just get it due to chance alone. So therefore, C would be the correct answer there. All right, and then the final one, and we talked a little bit about this the other day, number 37. I don't think I offered the best explanation, so I'll try again. So yeah, the answer is going to be E. We know that the power of the test would decrease. So whenever you change the p-value to a lower p-value, that decreases the power of the test. All right, so therefore it's going to be ones where the power of the test is decreasing. So that's going to be this one, and it's also going to be that one right there. So you did choose B, but you have to understand what the probability of a type 2 error means. So the probability of a type 2 error is failing to reject the null when in fact the null is false. And we are told the null is false. So what happens is, you have to be in this critical region at 5% in order to reject the null. But if you change it to 1%, that means it's actually harder to reject the null. So therefore, the probability of failing to reject the null just went up. So therefore, the answer would be E. Anyway, thank you very much for coming in yesterday. I thought you did a really good job. Hopefully these answers help. Apologize if it's because it's in the phone. I know I'm stuttering, so I'm just going to stop talking right now. All right, thanks very much. I'll see you in class. Bye-bye.